Hello, everyone. So, it's on a timer? Is that a way to stop that? Okay, I'll figure it out. So, if you're anybody like me, once spring rolls around, you're just itching to get out of the house and into nature, especially after a long Minnesota winter, as you can see out your window. However, one piece of tool that you can always see me using when I'm out in nature is a multi-tool. I mean, why wouldn't you? You have a multifaceted tool that has many functions all in a simple and compact device. However, a multi-tool can't do everything for you. That's why you need more complementary gear. And you need the right amount of gear and the right type of gear in order to make your term for it. In order to make you need the right amount of tools and the right type of tools to have the most pleasant experience in nature. However, for a farmer, they have a similar aspect. Once spring rolls around, they are itching to get out of the house and start planting their fields. The type and the amount of plants they want and can plant varies on different aspects. They need different nutrient sources, right equipment, but most importantly, they need nutrients. And manure is their multi-tool. Manure has many functions that benefits both the plant and soil, such as helping soils get to the right optimum pH levels for proper nutrient uptake. They can help elevate soil organic matter, but most importantly, they're a heterogeneous source of fertilizers, both macro and micronutrients. However, the mismanaged manure can lead to environmental harms, especially through nitrogen and phosphorus runoff or losses, and leaching as well. So manure is a multi-tool, but it can't do everything. There are other tools that a farmer may use a farmer may utilize in order to complement the manure they use, such as a cover crop or a non-commodity crop used in the fallow season each has their own specific function and environmental services. Here you can see cereal rye, a grass type cover crop, flourishing and growing during the corn V5 growing season and onward. So I wish I had that. Well, yeah, so my research focuses on how the integration of liquid injected manure and cover crops impacts soil health, nutrient cycling, and agronomic production. Farmers typically apply the manure in the late fall when there are not many active nutrients or active roots in the soil present to take up those readily available nutrients right after fall manure application. So we're hoping that if we are first interseeding a cover crop into corn, we're allowing that cover crop to have an established root system. So once we come later on in the fall and apply manure into the cover crops, those roots can take up those active roots in order to take up those nutrients and also provide any other services that those cover crops may provide. So the intent of my research is to not only look at the integration of cover crops and manure and how that impacts soil health, nutrient cycling, and agronomic production, but also to make best management practices for farmers to be able to use these systems in the upper Midwest agronomic systems, or yeah. Sorry. But yes, I'm happy to answer any questions. Hopefully I will be defending in a couple months, so this is kind of a little like taste of what my presentation will be and what I will have to present in a couple months after doing my data analyses and get my presentation all ready. And so happy to answer any questions.
You're looking at different modes or methods of application, or is it a single method?
For manure?
Yeah.
Yeah. So Dr. Julinski is asking if we are looking at different modes of manure application. In our system, we are looking at sweep injecting manure, since that shows to be the most prominent way of injecting manure into cover crops without damaging too much in the fall. So they're able to recover once spring comes in. So.
And what does that actually look like?
Yeah, so this is what we do in early and late fall. You can see that the disc kind of opens up the soil. Then you have these sweeps that allow you to inject soil into the ground. So that also helps sequester nutrients like nitrogen and phosphorus, because if you get that nitrogen in the soil, there's less chances of phosphorus runoff and nitrogen losses through ammonia volatilization. There is also a risk of nitrogen leaching if the soil is too warm. So that's why University of Minnesota recommends you apply manure when soils are at or below 50 degrees Fahrenheit or 10 degrees Celsius, because that'll actually limit the amount of nitrification happening, so you have less chances of nitrogen losses in the late fall.
Questions about mine? It's from a couple of perspectives that goes to like how deep does it?
It's about 5 to 6 inches deep into the soil.
And for your cover crops, were you mostly just working with cereal rye, or were there a variety of them?
So we have 3 different rotations. We have a sweet corn, a grain corn rotation. We have, which that looks at 3 different types of cover crops: a single species cereal rye, single species oat, and a rye oat radish mixture, as well as an oat cover crop. In our other systems, we are looking at cereal rye and annual ryegrass mixtures only. We don't have like the monocropping cover crop. But in our soybean corn rotation, we're looking at the different ways of planting them. So we're overseeding them at soybean leaf drop as a way to interseed them, and we're drilling them after soybean harvest. In our other system, it's a continuous silage corn system. And that one we're broadcasting by hand at around V5, R5. Then we're also coming in and drilling after corn harvest. So we're trying to see if we can come in and plant early. Does that improve cover crop yield, biomass accumulation, the efficiency of that?
Okay.
So far we've seen that with the continuous silage corn, planting it around R5 is the best, because obviously you want to have as long of a cover crop growing period, but V5 is a little too early, because once that corn starts having their canopy start expanding, that's a lot less light penetration to the soil ground. So you can see, like right now, like, let's see, it's pretty, it looks like a good stand of cover crops, but over time the cover crops won't have that much of a biomass accumulation compared to when we applied at R5 or when we planted at R5.
Okay. And you collected biomass data in the fall and the spring?
Yeah, so we collected cover crop biomass sampling prior to the first frost, since we do have that annual ryegrass, which is winter intolerant, so is the radish. We're also coming back around April time, right before cover crops are chemically terminated, to also collect biomass. And from those, we are looking at corn, carbon and nitrogen in both the fall and the spring. And in the spring, we're also looking at phosphorus uptake of cover crops too. Then come corn harvest, we're looking at a slew of different nutrients, from the macros to the micros, like copper, aluminum, zinc, all of them. So we'll have a pretty robust nutrient uptake analysis, hopefully. In the back.
These are all plot scales?
So the question is, if these are all plot size? Yeah, these are small plot studies. Each plot is about four corn rows wide. It's about 10 by 30, I believe, is the dimensions, feet.
And then it's challenging to get the manure application implemented to all those plots, or are the manure applications applied to all of them?
So I guess, yeah, so the question is it easy to get the manure application easily across all the plots? So the answer to that is, these are randomized complete plot design with split plots. So our main plot is a manure. So we'll have like the manure go through the whole, the whole field basically in each strip. Then within each of those subplots is the cover crop treatment, which is more easy to, plant and, manage, because most of it is done by hand and then also by a small tractor and seeder. Yes. The question is, how are we analyzing the biomass of the cover crop? So we are using 0.5 by 0.5 millimeter quadrats. We use 2 of those in each of the plot where cover crops are planted. And so we kind of focus our quadrats to be in the middle 2 rows of the four row system. So we're cutting the biomass up to the soil level, and we are excluding weeds out of the analyses. So we'll take it back, we'll dry them in the ovens and crop services. I believe it's around 140 degrees Fahrenheit until they're constant mass, and then we're measuring their dry weight matter to look at their yield. Then after that, we are grinding them, and we send them to Brookside to be analyzed for carbon, nitrogen, and phosphorus. So carbon, nitrogen is being analyzed by combustion analyses, and phosphorus is being analyzed through the nitric acid hydrogen peroxide digestion method with I believe it's a microwave digestion, but that's how we do it.
Well, if there's no more questions, thank you, Manny.